Hello everyone, my name is Anisha and the topic of my presentation is illumination models. Let us start with photorealism. Photorealism is an art that includes painting, drawing and other graphic media in which the artist studies the photograph and then attempts to reproduce the image as realistically as possible. Photorealism evolved from the pop art, which is an art movement that emerged in the mid-1950s in Britain. Light source. A light source is an object that radiates energy. It is an optical transmitter that is paired with an optical receiver. The whole system is connected to an electrically based circuit. Attenuation intensity. Attenuation intensity is a gradual loss of intensity of the light source through a medium. Decrease in the intensity of the light beam is due to the absorption of energy and scattering out of the path of the detector. But it does not include the reduction due to the geometric spreading. Light sources near and far means the light sources placed near the objects, which are called near light sources, and the light sources which are placed far away from the objects are called far light sources. Spotlights. Point sources whose intensity falls off away from any given direction is called a spotlight. It requires a color, point, and direction. These parameters control the rate of fall-off. Spotlights have a cone effect. Angular attenuation. Angular attenuation is defined as the degree where light nearer the edges of the cone becomes less and less brighter compared to the light at the center. Flaps and cones. To restrict a light effects to a limited area of scene, Warner implemented flaps and cones. Flaps modeled after the barn doors found on professional photographic lights confined the effect of lights with coordinates of x, y, and z. Each light has 6 flaps corresponding to user specified minimum and maximum values in each of these quadrants. It is possible to create sharply delineated spotlights through the use of cones whose apex is the light source and whose axis lies along the L'. Color. Color is a visual perceptual property corresponding to humans to the categories called red, blue, yellow, etc. Most graphic displays of realistic scenes are in color. To incorporate color, we need to write the intensity equations as a function of color properties of light sources and object surfaces. Additive colors is created by mixing together 2 or more different colors. Red, green, and blue are additive primary colors normally used in this system. The diffuse reflection coefficient would then have RGB components. By adding red to green yields yellow, and by adding all the 3 primary colors, we get white. Subtractive coloring uses dyes, pigments, or filters to absorb some wavelengths of light and not the others. When they are added, wavelengths are absorbed or subtracted from white light, so light of another color reaches the eye. Any non-zero red or green components in the incident light are absorbed and only the blue component is reflected. The intensity calculations for this example reduces to a single expression. Specular reflection. It is a mirror-like reflection of light from the surfaces in which light from the single incoming direction is reflected into a single outgoing direction. It is described by the law of reflection, which states that direction of incoming light and the direction of outgoing reflected light makes the same angle with respect to the normal surface. Thus, the angle of incidence is equal to the angle of reflection, and the incident normal reflected directions are coplanar. Ambient light. The available light or ambient light refers to any source of light that is not explicitly supplied by the photographer for the purpose of taking photos. The term usually refers to sources of light that are already available naturally, like the sun, or artificial lights that are already being used, like a light bulb. Available light can often produce a color cast with color photography. In some cases, ambient light may be used to fill, in which case additional lighting provides the stronger light sources, for example a bounce flash photography. A relative intensity of ambient light and fill light is known as the lighting ratio, and an important factor in calculating the contrast in the finished image is known as Lambert cosine law. Lambert's cosine law says that the radiant intensity or luminous intensity observed from an ideal diffusively reflecting surface or ideal diffuse radiator is directly proportional to the cosine of the angle theta between the direction of the incident light and the surface normal. Surface which obeys Lambert's law is said to be Lambertian. In general, the luminous intensity of a point on a surface varies by direction. For a Lambertian surface, that distribution is defined by the cosine law with peak luminous intensity in the normal direction. Thus, when the Lambertian assumption holds, we can calculate the total luminous flux from the peak luminous intensity by integrating the cosine law, as given below. Ambient reflection models. The parts of scene are not directly lit by light sources. They can still be visible because of the indirect illumination. Ambient light IA is an approach to this indirect illumination. Ambient light is independent of light sources and the viewer's position. The total intensity I total at a point P can be given by using the following equation. Here are some of the examples for the ambient reflection model. Diffuse reflection model. Diffuse reflection is the reflection of light from surfaces such that an incident ray is reflected to many angles rather than to just one angle, as in a case of specular reflection. An illuminated ideal diffuse reflecting surface will have equal luminescence from all directions which lie in half space adjacent to the surface. The visibility of objects excluding light emitting ones is primarily caused by diffuse reflection of the light. It is diffusely scattered light that forms the image of the object in the observer's eye. For the background lighting effects, we can assume that every surface is fully illuminated by the scene's ambient light IA. Therefore, ambient light contribution of the diffuse reflection is given by I ambient diffusion equals to KD IA. Ambient light along with very uninteresting For background lighting effects, we can assume that every surface is fully illuminated by the scene's ambient light IA. Therefore, the ambient light contribution is direction. The angle between the incoming light direction and the surface normal is referred to as the angle of incidence given by theta. The amount of incident light on the surface can be given by IL cos theta, and the diffusion reflections are given by KD IL cos theta. Assuming we denote the normal for the surface as n and the unit direction vector to the light sources as L, then n cross-pointed with L gives cos theta. Here are some of the diffusion reflection models. Specular reflection model. Specular reflection is when the reflection is stronger in one viewing direction, that is, there is a bright spot called a specular highlight. In a perfect specular reflection, the light is only reflected along a unique direction symmetric to the incoming light. So, if R is in the direction of specular reflection and V is in the direction of the viewer, then for an ideal reflector, the specular reflection is visible only when R and V coincide. For real objects, the specular reflectance, the smaller the range of specular visibility. Phong reflected ray can be given by this equation, where n varies with material, I is the intensity of the light source, V is the view direction, R is the direction of the perfect reflected light, Ks is the specular reflection coefficient, and I is the reflected intensity. Here are some of the examples for specular reflection model. Specular reflection functions. Many opaque specular reflection is nearly constant. Advantages are, for a non-planar surface, n cross-point with H requires less computation than V cross-point with R because R is related with n, which is used in specular lighting and represents the normal at micro imperfections in the surface, which would cause incoming light to reflect towards the viewer. An alternate way to compute Fong's lighting is given by this equation. It is faster than Phong in the case where the viewer and light are treated to be very remote, such as approaching to an infinity. This is the case for directional lights and orthographic cameras. The halfway vector is independent of position and surface curvature simply because the halfway vector is dependent on directions to viewer's position and the directions to light's position, which individually cover this remote distance. Hence, the halfway vector can be thrown off as constant in that case. Blend-Phong reflection method uses halfway vector computation techniques, and here are the images. Color component. The RGB color model is an additive color model in which red, green, and blue lights are added together in various ways to reproduce a broad array of colors. The name of the model comes from initials of the three additive primary colors red, green, and blue. Main purpose of the RGB color model is for the sensing, representation, and display of images. One common application of the RGB color model is to display the colors on a cathode ray tube, a liquid crystal display, plasma display, organic light emitting diode, a color wheel with RGB pixels of the color are given below. Multiple light sources. Multiple light sources each created their own pattern of light and shade. An area lit by two equal light sources give off twice as much light energy as an area lit by only one, by looking much less than twice as bright. One result of this is that areas of overlap of shadows that get no light from either sources tend to be conspicuously dark compared to areas lit by one source as shown in the figure below. Transparency. Opaque objects. An opaque object is an object that light cannot pass through. The light is either reflected, scattered, or absorbed. Examples are wood, etc. Transparent objects. Transparent objects are those that allow large quantities of light to pass through, air, water, etc. Transparent objects vary in the amount of types of lights that they let through their surfaces. Translucent. Translucent objects allow light to pass through them partially, but they diffuse the light in a way that makes objects on the opposite side appear blurred. Some of the examples are butter paper. Snell's law. Snell's law is formula used to describe the relationship between the angle of incidence and refraction. While referring to light or other waves passing through the boundary between two different isotopic media such as water or glass. Snell's law states the ratio of the signs of angle of incidence and refraction is equivalent to the ratio of phase velocities in the two media, or equivalent to the reciprocal of the ratio of incidences of refraction. Opacity and multiple objects. The degree to which light is not allowed to travel through is called opacity. Describes the absorption and scattering of radiation in the medium such as glass, shielding material, etc. Different processes can lead to opacity including absorption, reflection, scattering. Opacity settings in computer graphics software allows you to adjust the transparency of an image. Visibility from the eye. The practice of engaging a visual perception unaided by a magnifying or light collecting optical device such as a telescope or microscope. This visual perception allows a person to gain more information about their surroundings. A shadow. A shadow is a dark area where light from light sources is blocked by an opaque object. It occupies all the three-dimensional volumes behind an object with light in front of it. Assumptions to form a shadow. A shadow can be formed only when there is a single light source, finite area light source, and an opaque object. Shadow is divided into umbra, penumbra, and antumbra. Shadows are generated by the following techniques. Scale line generation of shadows. One of the oldest methods for generating shadows is to augment a scale line algorithm to interleave shadow and visible surface processing. Using the light source as a center of projection, the edges of the polygon that might potentially cast shadows are projected onto the polygons intersecting the current scale line. When the scan crosses one of these shadow edges, the color of the image pixels are modified accordingly. A brute force implementation of this polygon must compute all n into n-1 projections of every polygon on every other polygon. While the scanline algorithm's regular scan keeps track of which regular polygon edges are being crossed, a separate parallel shadow scan keeps a track of which shadowing polygon projection edges are crossed, and thus which shadowing polygon projections the shadow scan is currently in. This can be viewed in the following figure. The second technique is a two-pass object precision shadow algorithm. Ayrton, Weyler, and Greenberg have developed an algorithm that performs shadow determination before visible surface determination. They process the object description by using the same algorithm twice, once for the viewpoint and once for the light source. The results are then combined to determine the piece of each visible part of the polygon that are lit by the light sources, and the scene is scan converted. Thus, since the shadows are not dependent on the viewpoint, all the shadow calculations may be performed just once for a series of images of the same object seen from many different viewpoints, as long as the light sources and the objects are fixed. Multiple light sources can be handled by processing the merged databases from the viewpoint of each new light source, merging the result of each pass. Here is the diagram. It should be noted that once we have located these shadow areas for all the light sources, the shadows could be treated as surface patterns and are stored in the pattern arrays. Here are the different shadow patterns. Perceived intensities. Luminous intensity is a measure of the wavelength wave power emitted by a light source in a particular direction per unit solid angle, based on the luminosity function, a standardized model of sensitivity of the human eye. The human eye responds to low light levels by enlarging the pupil, allowing more light to enter the eye. This response results in the difference between measured and perceived light levels. A lamp that is dimmed to 10% of its maximum measured light output is perceived as being dimmed only 32%. Likewise, a lamp dimmed 1% is perceived to be at 10%. The formula for perceived light is given below. Gamma correction. Gamma correction, or often simple gamma, is the name of a nonlinear operation used to encode and decode luminescence values in a video or still image system. Gamma correction is the simplest case and it can be defined as the power law expression. Required intensity level for high quality viewing. Visible light range is from 400 to 700 nanometers. Hue is the dominant the spectral components. Saturation, excitation, purity determines how far the color is from gray. Brightness is the luminescence of a self-luminous object. Intensity level resolution. It refers to the number of intensity levels used to represent the image. The more intensity levels used, the finer the level of detail is present in the image. Intensity level resolution is usually given in terms of the number of bits used to store at each intensity level. Halftone is a reprographic technique that simulates continuous tone image through the use of dots, varying either in size or in space, thus generating a gradient-like effect. Halftone can also be used to refer specifically to an image that is produced by this process. When the continuous tone image contains an infinite range of colors or grays, the halftone process reduces visual reproduction to an image that is printed with only one color of ink in dots or different sizes or spacings. This reproduction relies on basic optical illusion. The tiny halftone dots are blended into smooth tones by the human eye. At the microscopic level, developed black and white photographic films also consist of only two colors and not an infinite range of continuous tones. The semi-opaque property of the ink, which is used in the halftone dots printing, can create another optical effect known as full color imagery. Intensity. The resolution of halftone screen is measured in lines per inches. This is the number of lines of dots in 1 inch, measured parallel with the screen's angle. The higher the pixel resolution of the source file, the greater the details that it can produce. However, such increase also requires a corresponding increase in the screen rolling, or the outputs will suffer from posterization. Often we have limited range of intensities with more than adequate spatial resolution while using halftoning. Dot patterns. Though round dots are most commonly used, there are different dot patterns available, each of them having their own characteristics. They can be used simultaneously to avoid the Morse effect. Generally, the preferred dot shapes is dependent on the printing method and the printing plates. Round dots, most commonly used, and they are suitable for light images. Elliptical dots, appropriate for images with many objects. Square dots, best for detailed images and are not recommended for skin tones. The dots cannot easily be seen by naked eye, but they can be seen through a microscope or a magnifying glass. Dot pattern problems. The problems with printing halftone dots is that the dot will grow in size as the ink is pushed out of the mesh onto a soft surface like a cloth. A halftone will grow from 25% to 35% when printed properly. If printed poorly, it can grow to twice its size. This means that the print will be muddy with no details. Approximating halftone images. If we cannot display all the required intensity levels, we need a trick using the spatial integration that our eyes perform. In normal light, the eye can only detect about 1 arc minute. This is called visual acuity. Thus, instead of gray dot, a small black disc with radius varying according to the blackness is printed. Usually for newspapers, 60 to 80 per, and for magazines, 150 to 200 radiuses are used. This process is called halftoning. Dithering techniques. Another technique used for generating digital halftoning images is dithering. Unlike patterning, dithering creates an output image with the same number of dots as the number of pixels in the source image. Dithering can be thought of as a threshold that source image with a Dither matrix. The matrix is laid repeatedly over the source image. Whenever the pixel value of the image is greater than the value of the matrix, a dot on the output image is filled. A well-known problem of dithering is that it produces artifacts of patterns introduced by fixed thresholding matrices. The first synopsis uses a default Dither matrix to threshold the input image. The default Dither matrix is given below. This matrix is a rectangle Dither matrix extracted from a 45-degree Dither matrix. A 45-degree Dither matrix can make artifacts less obvious. The second synopsis, on the other hand, uses the Dither matrix defined by the user. Dither reads in an input image, compares each pixel with the corresponding element in the Dither matrix, generates the output image and writes it into the output file, which is in the form TIFF. Error diffusion. Error diffusion is a type of halftoning in which the quantization residual is distributed to neighboring pixels that have not yet been processed. Its main use is to convert a multi-level image into a binary image. Unlike many other halftoning methods, error diffusion is classified as an area operation because what the algorithm does at one location influences what happens at the other location. This means buffering is required and complicated parallel processing. Error diffusion has a tendency to enhance edges in the image. This can make text in the image more readable than in the other halftoning techniques. Error diffusion takes a monochromatic or color image and reduces the number of quantization levels. A popular application of error diffusion involves reducing the number of quantization states to just 2 per channel. This makes the image suitable for printing on binary printers such as black and white laser printers. It is assumed that the number of quantization states in the error diffused image is 2 per channel unless otherwise stated. Error diffusion. Error diffusion can be done in various ways. Freud-Steinberg take the error and distribute it using the ratios given below. Remember that we are doing a raster scan. One-dimensional error diffusion. This is the simplest form of algorithm scans the image one row at a time and 1 pixel at a time. The current pixel is compared to a half-gray value. If it is above the value, a white pixel is generated in the resulting image. If the pixel is below the halfway brightness, a black pixel is generated. The generated pixel is either full bright or full black. So there is an error in the image. The error is then added to the next pixel in the image and the process is repeated. Two-dimensional errors. One-dimensional error diffusion tends to have severe image artifacts that show up as distinct vertical lines. Two-dimensional error diffusion reduces the visual artifacts, and simplest algorithm is exactly like one-dimensional error diffusion, except half the Two-dimensional errors. One-dimensional error diffusion tends to have severe image artifacts that show up as distinct vertical lines. Two-dimensional error diffusion reduces the visual artifacts. The simplest algorithm is exactly like one-dimensional error diffusion, except half the error is added to the next pixel and 1/4 of the error is added to the pixel on the next line below and 1 pixel forward. This is the given kernel, where the hash denotes the pixel currently being processed. Further, refinement can be had by dispersing the error further away from the current pixel, as in the matrix given below. To enter the further refinement can Error diffusion may also be used to produce output images with more than 2 levels. This has application in display and printers which can produce 4, 8 or 16 levels in each image plane, such as electrostatic printers and displays in compact mobiles, telephones, etc. Rather than using a single threshold to produce binary output, the closest permitted level is determined and the error is rectified. Here are the references that I went through. Thank you for bearing with me.